right, these are the notes for 10-3. The first two slides are a review. I'll move pretty quickly through those, but please feel free to pause at any time, try them yourself, and then come back and check the answers. So in the first part, we're reviewing what we did back in chapters 3 and 4. We're going to factor out the GCF. So you're going to have the GCF of 3, and then you'll write down what's left over. We kind of call this the distributive property backwards. Hey, remember? Let me see if I can get this to do this by itself. So 7 and then 14, the GCF is 7. When I factor that out, I'm left with x minus 2. Again, you can push pause at any time and try the rest if you weren't sure what to do. Okay, over here, I have no numbers in common, but I do have a variable in common. So I'm going to factor out the y. At some point, maybe this will start picking red. Over here, make sure to remember that you're dividing each, so it's using those exponent rules we've used before. So it should be a +1. You need to kind of save that spot. Remember, you can check by distributing the 7x back through and making sure that's what you originally had. Okay, over here, I have a 4 as a GCF of the numbers, but also an x. So that gives me a plus 3b here. And again, checking, multiply that through. Sorry, this should be an a, not an x. 4x times a gives me 4ax. 4x times 3b gives me the 12bx. On the next slide, again, you can push pause, work through these yourself. These are working through examples like we did in Chapter 5, where we are factoring. As a reminder, some of you did the boxes where we, let's see if I can remember how to do this. And you should be able to look back in your Chapter 5 notes. We did the area model, that's what most of you liked, or we had this is x squared, we had 10 here. And we said, okay, well, what multiplies to be x squared? X and x. We said, what multiplies to be 10? You could pick a couple different things, but I'll choose 2 and 5. And then we checked, and we said, okay, well, 2 times x is 2x. 5 times x is 5x. And then we said, okay, well, I got to check. Is 2x plus 5x equal to 7x, which is the middle term here? It is, so our answer was x plus 2 times x plus 5. Similar ways you can work through this one. Okay, where I put 7x squared here. Oh, my goodness. And 2 here. So what gives me 7x squared? X and 7x. What gives me 2? 1 and 2. And then you can multiply that out. This gives me 14x. This gives me x. Is x plus 14x 9? No, that doesn't work. So we're just going to switch the numbers. So now I'm going to try, it's up here before was the 1. Now I'm going to try to put the 2 here and the 1 here. Okay. Sorry. Okay. Now when I do 2 times x, I get 2x. 1 times 7x is 7x. So does that give me the 9x I need? Yes. So my answer to that one, when it's factored, is going to be, you're going to look at the sides. 7x plus 2, I'm getting that from the top, and x plus 1, I'm getting that from the side here. So again, you can go ahead and you can work through. You're always looking for this direction to add to be the middle. I'm going to just write the answers now. So push pause, work through, and then come back and check. Okay. Oh, good gravy. 2x so -9, okay. This one, remember, you want your middle term to add to be 0. Okay. Oh, this is driving me crazy. It won't stay one color. X. Over here. I have x plus 6, x minus 2. I'll just read you the answers for the other ones. Down here, this will be x plus 7, x minus 7, and this will be x minus 12, x plus 4. Again, if you need help on this, look to Chapter 5 or come see me. And basically what we're going to do is we're going to take those two ideas of those slides and combine them together. So if we had to factor out 3x squared plus 30x plus 48, we could do that with the box, but there's a lot of combinations that multiply to be 48. So we're going to look to factor completely. Now, factoring completely is breaking it down kind of into its primes. For example, in 12, we could say 2 times 6 is 12. But if we said factor it completely, then you would say 2 times 2 times 3 is 12, breaking it down as far as you can. So the first thing that we're going to do is factor out the greatest common factor. And that gives me 3 x squared plus 10x plus 16. After that, you're going to now factor what's left in the parentheses, which is a lot easier than what it was before. So you have 3, the answer is right here, this last part. So you factor out the greatest common factor, then factor what's left in the parentheses. You're going to do the same thing here. Again, I encourage you to work through these yourself and then come back and check. Over here, I'm going to factor out a 5. That gives me 3x squared minus x minus 2. Bring the 5 down. You need that 5. And then you're going to factor the other part. This is like what you did before, so if you need help, again, you're going to have to go back and look at that. Let's see. So this is going to be a plus 2 and an x minus 1. Over here, I'm going to factor out the greatest common factor. And then I will factor what's left in the parentheses. Now this one up here, I'm going to factor out the greatest common factor. Now, some of you might get confused and try and pull an x or a y. Remember, it needs to be common to all 3. They don't share any variables to all 3, so I have to leave the variables alone. Now, with the y squared in the back, it's really not all that bad. We're still going to have an x in the front of each parenthesis, and you also know you're going to have a y in the back of each because you need those back numbers to multiply. So really just ignore the y for now. So if I multiply this back out, I would get the x squared. I would get, if you use your diagram, multiplied out, you can see I would have 3xy plus 4xy. That's giving me the 7xy. And then the 3y times the 4y is the 12y squared. So again, don't get too confused. It just means that the factors that you're going to use with 12, put a y with them. That's all that means. All right, I'm going to skip down to this one. This one has a greatest common factor of x squared. That's going to leave me with x squared minus 8x plus 12. Bring that greatest common factor down every time. And we're going to go x minus 6, x minus 2. So things that look crazy and you could never factor them become much easier when you look at the greatest common factor first. I'm going to go over to this one. This is the last one I'm going to do. If you want to try the other ones, that's fine. I'd be happy to check them in class for you. So that's going to leave me with x squared here plus 6xy. Oh, I'm sorry, that's plus 2xy. Minus 15y squared. So I'm going to bring down my greatest common factor. And again, don't worry about use the 15 just like you did before, and just put a y with its factors. And again, if you're not quite sure how does this, multiply it out, multiply the binomial out, and you'll see how it gets to here. The other ones, again, you can work on those. I'd be happy to check on them, but I think you get the idea. Factor out the greatest common factor. Make sure to bring that down. It's an expression. We're just changing the way it looks.